In this video, we are going to be diving into the first attack vector that we will be covering, which is known as OS command injection. The reason we have decided to cover this attack vector first is because the information shared in our two previous videos will directly relate to helping you understand how this attack works. Since we've covered how the Linux terminal works and how HTTP requests and responses work, the knowledge of those two concepts in combination with each other will help you understand how command injection attacks work. This attack is triggered via input passed to a HTTP request, and it makes use of specific terminal characters to execute commands on the backend terminal of the target server. So if you haven't watched our two previous videos already, then doing so is a good idea because they cover the same concepts that we will be using within this attack vector. We will be demonstrating how this attack can be exploited in a blind manner where we cannot see the results of what is happening, and also how this attack can be exploited normally. We will be providing code examples written in PHP in order to demonstrate how this attack works. We have built a PHP-based web application for demo purposes. It is split into two sections with a user control panel and an admin control panel and is vulnerable to both regular and blind command injection. You can find the code for this web application hosted on our GitHub. The link can be found in the description. You can use this vulnerable application to try out the techniques taught in this video against a real environment that has been made vulnerable to the techniques that we will be discussing. So to get started, let's cover what OS command injection attacks are in general and how they work. First, let's give a basic overview of the flow of traffic from a hacker's machine to a target server. Consider the following diagram. The hacker could choose a target, and using their machine, they could browse through the target site in order to attempt to identify a command injection vulnerability. Once a vulnerable endpoint has been identified, the hacker could craft a payload designed to execute system commands on the back end of the target server. They could then inject their payload into a vulnerable parameter. When their payload is sent, there will generally be a firewall or some form of input validation designed to prevent this. If their payload bypasses this validation, it will then be executed by the target server. This will result in the hacker system command being executed in the terminal on the backend server, essentially giving the hacker free rein to execute whatever commands they want on their target. They could run a command to create, update, read, or delete files on the target server, or they could do something such as spawn a shell as a means of maintaining access persistently. They could use their ability to inject system commands in order to modify the website that is hosted on the target server, allowing them to hack it and replace it with a defaced page. Before getting into the specific technical details as to how this attack actually works, let's show an example of different outcomes that could potentially take place based upon whether or not the attacker's payload gets caught by the web application firewall or by other forms of input validation. Let's show another diagram. But this time we will show some different scenarios that could take place based on whether or not the payload is caught by any filters. So to begin with, after having identified a vulnerable endpoint, the hacker uses their machine to craft their payload. They then try to inject their payload into the vulnerable parameter on the target site. But first the payload gets analyzed by the web application firewall. In this case, the firewall detects that it's a malicious payload and rejects it as a result. Seeing that their payload has been rejected, the hacker tries again, tweaking their payload to attempt to bypass the firewall. This time, the firewall isn't sure whether or not the payload is malicious, so it gets flagged for manual review. When the payload is reviewed, the person reviewing it notices that it is definitely malicious and rejects it as a result. After seeing that their payload has failed again, the hacker tries yet another time, tweaking it even further and resending it. This time it slips through the firewall, but unluckily for the hacker, a system administrator is monitoring traffic in real time and notices the payload. As a result, they block the payload themselves, preventing it from being executed and stopping the attack from taking place. Now that the hacker knows they at least have a working bypass method, they give it another try. This time, there is no system administrator reviewing traffic, so their payload slips past the firewall and gets executed successfully on the back end of the target server. The hacker could create a backdoor in the form of a reverse shell, resulting in the target server initiating a connection to their machine, allowing them to execute commands and view the results in real time. This gives them a two-way communication channel between themselves and the target server, allowing them to easily execute whatever commands they want whilst maintaining access to the server that they've hacked. What's actually happening behind the scenes here is that The developer has written some code which contains a system call function. These functions allow scripts running on the web server to invoke the terminal and execute commands on there. While these functions can be used in a secure manner, sometimes developers will pass an input that can be controlled by a user into these functions, and when this happens, the user-controlled input can be changed to a terminal command, resulting in execution of whatever code the user decided to input. In most scenarios, developers will pass a static input that cannot be controlled by a user into these functions. But depending on the functionality of what they're trying to develop, sometimes they will feel that it is necessary to pass a user-supplied input into a system call, for example, as an argument for an existing command. An example of this could be if they were wanting to create a script that allowed users to run a query to see who a domain name is registered to. So they write some code that allows the user to input a domain name, and then that domain name gets inserted into a system call as an argument for a whois command, allowing the user to perform a whois lookup on a domain of their choice. The developer script would have an HTML form where the user can input the domain name. Then it would take the value of the domain that the user submitted as a HTTP post request and use that value as an argument for the whois command within the system call. The following code will demonstrate an example of this. Here we have an HTML form, and we can see that it is sending the form input as a HTTP post request to the script that performs the whois lookup. We can also see that it is assigning the domain inputted by the user to a HTTP post parameter that is named URL. As for the script that the inputted domain name is being sent to, we can see that it is taking the user's post input for the domain name and assigning it to a variable. It is then taking this variable and inserting it into a system call as an argument for the whois command. We can see that the system call is running whois, and the variable is being passed into it as an argument. Finally, we can see that the result of the system call is being assigned to a second variable, and the value of that variable is being outputted to the page via echo. Instead of passing just a domain name and nothing else as their input, a user could pass a semicolon or ampersand character, followed by the command which they want to execute. Based on our Introduction to Linux video, we know that the terminal will cause two commands to be executed at once if these characters are detected. So it would execute both the whois command and also whatever malicious command the user decided to input as their payload, causing the results of both commands to be outputted to the page. The end result of this is referred to as remote command execution, which technically isn't a vulnerability itself, but is rather the impact of a vulnerability. In this case, it would be the resulting impact of an OS command injection vulnerability. Now that we've given a basic overview as to how these attacks work, we will cover the specific attack scenarios that are present within the intentionally vulnerable web application that we have created so that you can then play around with this application and use it to try out the techniques that are covered within this video. To get started, let's take a look at what the application is and what it is doing. First off, here's an image of what the regular user control panel looks like. It allows the user to select a program that they want to install based on some inputs from a drop-down menu. When an input is selected from this menu, HTTP post request is sent to let the server know which program to install. The server then inserts the program name into a system call in order to download and install it. However, a hacker could modify and resend the post request to change the name of the program to their payload, replacing the program name with the name of the command that they want to execute using a semicolon or another special terminal character, so that when their input gets inserted into the system call, it executes the command that they injected in addition to the original command. In this case, the output of our command isn't being outputted to the page, but instead it's being outputted to a page within the admin panel. This is known as blind command injection. Here we can see what the admin panel looks like, with some functionality showing files that the user has chosen to download and install. This is where the results of our command execution will be getting outputted. So while the results aren't visible to a regular user, the command is still being executed and the results are visible within the admin panel. Also within the admin panel, a regular command injection vulnerability that isn't blind can also be found. There is some functionality that allows you to input a URL to check whether or not a website is currently online. It does this by passing your input into a system call that executes a ping command to determine if the website is currently online based upon whether or not we're getting a ping response once the command is executed. We can exploit this in the exact same manner as the previous example, but rather than the results of our command execution being displayed on a different page, they are immediately displayed on the same page where we are inputting our commands, allowing us to see the results of our command injection attack straight away rather than those results being outputted elsewhere. Let's take a look at the actual PHP code, which is causing this vulnerability to exist. First, we'll look at the code for the blind command injection in the functionality for downloading and installing files. The following code snippet is where the vulnerability exists. First, it's checking that a value has actually been set for the file we want to download and install, and it is checking to make sure that the value isn't empty and that it actually contains some data. If this check is successful, then it inserts the value for the file we chose to download and install into system call as an argument for the wget command. It is then assigning the results of the system call being executed to a variable named DL. Since this attack is blind, the rest of the code for it can be found as part of the script for the admin panel. It is taking our DL variable and assigning it to a variable named CMDZ, using a session superglobal. The session superglobal allows us to easily call the same variable from between separate scripts, so it's being used here due to the DL variable being set within a different script. It is then generating the text where our results are going to be outputted, inserting the CMDZ variable value into part of an echo statement so that the value stored in that variable can get outputted. This is being assigned to a variable named download results, so that when the download results variable gets called, it will output some text that contains the input we provided. After this, it is doing another check to ensure that the provided inputs actually exist and that they aren't empty. Finally, once the check passes successfully, it is outputting the values stored within the download results variable, which contains the inputs that the user selected, which in our case would be the terminal command that we supplied as our input. The end result is the output of our command execution being displayed on the web page within the admin panel, via the actual front-facing web page. This PHP script is getting the information that it needs via the HTML form with a drop-down menu shown in the image earlier. Here is an example of what the code for that form looks like. It's using a basic input form for the drop-down menu with a list of options to select. When a user submits the form after selecting their option, we can see that it is sending the input to the PHP script for the user control panel. We can also see that it is assigning the input to a parameter named filename, which matches the parameter name that the PHP script is expecting to detect. Now that we've covered what the blind command injection looks like, let's take a look at the code for the regular command injection. It's very similar to our previous example, except this time the intended functionality is a ping command, and this time our output is being displayed on the same page as where our payload is inputted rather than elsewhere. It starts by taking the HTTP post input for the URL that was inputted by the user, and it assigns that input to a variable which is named URL. After this, it performs a check to make sure that the input supplied by the user was actually supplied, and that it isn't just an empty value. It then uses a system call to run the ping command, with the value supplied by the user passed to the system call to be used as an argument for the ping command. The results of this system call are then assigned to a variable named command output. This value is then inserted into some HTML so that the output can be formatted, and the formatted output is assigned to yet another variable named formatted. Finally, the formatted output containing the results of the system call that was executed with the input that we supplied inside of it is outputted to the web page so that it can be viewed by a browser. In terms of the front-facing HTML on the web page, it is yet another simple input form, except this time rather than a drop-down menu, it is a regular text-based input instead. We can see that it is using the HTTP post method to send our data, and that the data is being sent to the script for the admin panel. We can also see that the data that gets sent is being assigned to a post parameter named URL to ping, which matches the parameter name that the PHP script is expecting. Understanding how this code works isn't necessary to understand this attack, although it does help. If you don't understand the code examples, then that's fine. As long as you understand the concept of what a system call is, and the concept of using certain characters such as the semicolon to chain multiple terminal commands together, then this technique can be properly understood without needing any programming knowledge. We will give one final example which doesn't have a specific emphasis on the actual code involved. Like in the previous example, let's imagine the developer wants to pass user input into a ping command. doing so via a system call to run commands on the terminal. Here is what the command would look like, with the user-supplied input being the part in green. The developer would expect the user to input a regular domain name, such as example.com. If example.com was actually inputted, then here is what the system call would look like. With a system call that looks like that, the following command is what would be passed to the terminal. You can see the command that will be executed by the terminal as green text. But what if a hacker decided to supply something other than a URL as their input, such as a system command of their own? For this example, they would supply example.com as a URL like the developer was expecting. But then they would add a semicolon to signify to the terminal that a second command is going to be executed, followed by them inputting any command of their own choosing. I will now run some terminal commands to visually show you what would be happening on the back end of the target server if a hacker were to inject their own commands into a system call in this manner. We will start by typing out the ping command so we can emulate what would happen if the syscall executed and ran the command that the developer was expecting. We will then add a semicolon to signify to the terminal that a second command is going to be executed, and we'll input the uname-a command as an example. As you can see, it executes the ping command, but then it also executes the uname command too, causing the uname value to get outputted. Now let's use a second example, where we run cat against the password file alongside our ping command. As we can see, ping successfully runs, but so does our second command, disclosing the value of the password file. Although this took place within my own terminal, it is exactly what would be happening in the terminal for the backend server of the website we are targeting if we manage to inject a value into a syscall via an OS command injection vulnerability. If they're outputting the results to the page, then we can abuse this to see the results of any commands we want to execute in real time. We just wanted to make sure you understand the core concept of this attack for now, as we have 2 follow-up videos on this subject which will be going a lot more in depth. Part 2 will cover several dozen different filter bypass methods with examples of how to use them, and Part 3 will cover more advanced command injection scenarios alongside other attacks that are related to command injection. So in this video, we just wanted to introduce the basic concept to make sure you understand it before we move on to the advanced stuff. Thanks for watching, and keep your eyes peeled for Part 2.